Welcome, dear listener, to this quiet corner of the cosmos where we gently explore the universe together. Perhaps your day has been long, or perhaps you simply find solace in the soft glow of distant stars, the silent dance of galaxies, and the profound, tranquil mysteries that unfold across the vastness of space. Whatever brings you here, this journey is crafted just for you. There is nothing you need to do now, save for allowing your body to find its rest, your mind to gently slow its pace, and your thoughts to softly drift, like cosmic dust in the void. For tonight, we embark upon an exploration of the universe itself, not merely a single galaxy or a solitary star, but the immense, expanding whole. We will move with a gentle rhythm from one cosmic wonder to the next, quietly learning about the enigmatic nature of black holes, the ancient whispers of light traveling across eons, the unseen presence of dark matter, and the serene beauty of galaxies far, far away. Some of these quiet revelations may stir a gentle sense of wonder within you, while others may simply settle into your mind, like a peaceful thought at the very edge of sleep. Now, if you are ready, let us begin this tranquil voyage. As we gently drift through the cosmic expanse, a quiet question often arises. Could the universe be even older than we currently imagine? Most of our current estimations softly suggest an age of approximately 13.8 billion years, a number carefully derived from observations of the cosmic microwave background and the gentle expansion of space itself. Yet, in the quiet corners of scientific inquiry, not all methods perfectly align. Some ancient stars and distant galaxies seem to whisper tales of an even longer existence, hinting at ages that might gently push against our current estimates. Other inquiries softly ponder the assumed rate of cosmic expansion, or consider the possibility that dark energy, that mysterious force, might be subtly shifting over the eons. While these gentle mysteries remain, most astronomers still quietly embrace the 13.8 billion year figure, yet the questions linger, like distant starlight. Could the universe truly be older? Did we perhaps overlook a subtle clue in its history? It is a peaceful thought that what we perceive as the beginning might simply be one chapter in a much longer, more wondrous story. As we ponder the universe's vast timeline, let us also consider the solitary wanderers within it. In the deep silence of space, countless rogue planets are quietly drifting, unbound by any star. Not every world finds its home in a solar embrace. Some are completely free, floating in solitude through the galaxy, without a sun to warm their surfaces or illuminate their skies. These solitary wanderers may have once formed within a star system, only to be gently cast out by the gravitational ballet of their cosmic siblings. Others might have quietly coalesced on their own, like stars that never quite ignited. They are dark, cold, and nearly invisible, revealing themselves only when they softly pass before distant background stars or emit a faint, infrared glow. Astronomers quietly estimate that billions of these silent worlds may exist within our own Milky Way, perhaps even outnumbering the stars themselves. Each one is a tranquil sphere, a quiet drift in the profound darkness, spinning gently alone in the vast, empty spaces between the stellar nurseries. There are no sunrises, no sunsets, just an endless, soft night, occasionally touched by the distant, shimmering light of other stars. Perhaps the universe gently recycles itself through an endless dance of cosmic cycles. While the familiar model of cosmology describes a universe that began with the Big Bang and may continue its expansion indefinitely, some theories invite us to imagine a different narrative, one where the cosmos gracefully moves through rhythmic cycles of expansion and gentle collapse. In these contemplations, the universe does not conclude with a cold, quiet fade or a final, dramatic crunch. Instead, it softly resets. After reaching a certain expansive point, it might quietly bounce, slowly collapsing inward, only to rebound into a fresh, new expansion. Each of these grand cycles could gently erase the old structures, yet perhaps preserve subtle, whispered traces of what came before. These ideas, while speculative, are profoundly intriguing. They suggest that the universe may possess no true beginning or end, but rather an eternal rhythm stretched across unimaginable spans of time, with one universe softly giving rise to another, over and over again. This eternal rhythm echoes in the most ancient light we are able to perceive, originating from a time approximately 380,000 years after the Big Bang. Before that pivotal moment, the universe existed as a luminous, glowing fog, so incredibly hot and dense that light could not journey far without scattering and being absorbed. But as the cosmos expanded and gradually cooled, it reached a profound turning point. Atoms began to form, the dense fog quietly cleared, and light was suddenly set free to move through the vastness. This ancient, liberated light is what we now know as the cosmic microwave background, and its gentle glow can still be detected by us today. It represents the oldest direct signal in the universe, not emanating from distant stars or galaxies, but from the universe itself when it was just beginning its journey toward transparency. The photons we observe now have been traveling for more than 13 billion years, softly stretched by the continuous expansion of space into long, cool microwaves. This light is faint, yet ever present, a quiet, pervasive glow that carries within it the serene memory of the universe's earliest clarity. Imagine, if you will, that some distant stars cradle planets composed almost entirely of diamond. In the quiet depths of certain solar systems, the very chemistry that shapes worlds can be profoundly different from our own. Should a planet begin its formation with a greater abundance of carbon than oxygen, and if the pressures within its core reach extraordinary levels, something truly remarkable can unfold. A diamond planet. Astronomers have, in fact, quietly observed at least one such candidate, a dense world gently orbiting a pulsar, which is likely the serene remnant of a star that has completed its luminous journey. Based upon its measured mass, its profound density, and its elemental composition, it is believed that this entire planet may exist as a crystalline form of carbon, essentially a colossal diamond. While it would be far too warm to exhibit a sparkling brilliance and would not resemble a polished jewel, up close, deep beneath its surface, immense carbon lattices could quietly extend for thousands of kilometers. These extraordinary worlds are not common, yet they serve as a gentle reminder of the boundless diversity that graces our universe. A planet formed of rock, a planet composed of gas, and sometimes a planet crafted from crystal. From the wonders of planetary composition, let us now expand our thoughts to the very shape of space itself, which may possess no discernible edge, but rather an endless, gentle curvature. It is a natural inclination to envision the universe as something with a boundary, a distant border we might eventually reach if we journeyed far enough. Yet, the fabric of space does not appear to behave in such a manner. According to the profound insights of general relativity, the very shape of space is subtly determined by its contents. And current observations gently suggest that the universe is either truly infinite or so immensely vast and gracefully curved that it ultimately loops back upon itself. If this quiet truth holds, one could, in theory, embark on a journey in a straight line forever, and eventually, without ever encountering a wall, return to the very point from which they began, simply by gracefully wrapping around the curved expanse of space. This concept is akin to how a journey around our own Earth does not reveal an edge, but rather a continuous, gentle globe. The universe, on a scale far grander and more profound, may operate in precisely the same way, not infinite in its physical space, but infinite in the quiet, unfolding journey it offers. Imagine, if you will, that our sun once had a silent companion, a twin star that may still be drifting somewhere in the vast cosmic ocean. Some astronomers gently ponder the idea that our sun was not born alone, but rather emerged with a sibling, a companion star quietly forming from the very same cloud of gas and dust over 4 billion years ago. It is a common occurrence for stars to form in pairs, and there is a quiet logic in considering that our own sun might not have been an exception to this celestial dance. If this lost sibling ever existed, it would have long since drifted away, slowly pulled apart by the gentle, persistent gravitational tug of the Milky Way galaxy itself. Perhaps it still journeys out there, orbiting the galactic center on a different, unseen path, now invisible to our searching eyes. Some theories, whispered among the stars, even link this hypothetical twin, sometimes playfully nicknamed Nemesis, to mysterious patterns of extinction here on Earth, though for now, this remains a quiet speculation, without solid evidence. Yet, the idea softly lingers that our sun, so steady and seemingly alone in our sky, may once have shared its very birth with a silent partner, long since vanished into the endless tapestry of stars. Just as the sun's potential twin remains an unseen presence, let us now turn our thoughts to something truly profound in its density, where invisible forces shape matter in extraordinary ways. A single raindrop of neutron star material would weigh more than Mount Everest. Neutron stars are the collapsed, incredibly dense cores of massive stars, the quiet, heavy remnants left behind after the grand spectacle of supernova explosions. These celestial bodies are remarkably small, perhaps only about 20 kilometers across, yet their mass quietly surpasses that of our sun. The very matter within them is packed so incredibly tightly that a single teaspoon of it would weigh billions of tons. If one were to imagine a single raindrop, no larger than a tear, made of this neutron star material, its weight would exceed that of any mountain on Earth, a concept that gently defies our everyday experience. Within these stars, atoms are crushed together with such immense force that electrons and protons merge, quietly transforming into neutrons, forming a kind of superfluid neutron soup. Neutron stars are indeed extreme objects, small, dark, immensely heavy, and often spinning with a quiet, rapid grace. Yet, in their profound and quiet mass, they hold the ancient memory of stellar collapse, a final, serene state where matter becomes almost pure gravity, a silent testament to the universe's quiet power. As we gaze across the cosmos, it's fascinating to consider how light from a distant galaxy can sometimes reach us from not just one, but multiple directions. You see, light doesn't always travel in a perfectly straight line. In those profound regions of space, where gravity exerts an especially strong influence, perhaps near immense clusters of galaxies, space-time itself gently curves. This subtle curvature then bends the path of light, much like a lens of glass might softly redirect a beam. This phenomenon is known as gravitational lensing, and one of its most intriguing effects is that we can occasionally perceive multiple versions of the very same distant galaxy, each appearing from a slightly different angle. These ethereal images might manifest as delicate arcs, soft smudges, or even complete, shimmering rings. They are not true duplicates in the vastness of space, but rather duplicates in our vision, reflections of the different paths that light has quietly taken through warped space-time to finally reach our eyes. In a few rare instances, astronomers have even observed the same supernova explosion seemingly unfold more than once, as its light arrived through these varied gravitational routes. It serves as a quiet reminder that in the universe, even light can embark on a longer journey, taking a winding path, and yet still find its way home to us. And as we contemplate these ancient, winding paths of light, let us drift back even further to the very beginning to imagine the first stars, which may have burned 1,000,000 times brighter than our sun. These primordial stars were truly unlike anything we witness today. Born from the pure hydrogen and helium left in the gentle aftermath of the Big Bang, these celestial bodies, often referred to as population 3 stars, likely formed without any heavier elements at all, making them incredibly massive, intensely hot, and destined for a brief existence. Some may have possessed hundreds of times the mass of our sun. They would have consumed their fuel with astonishing speed, shining perhaps 1,000,000 times brighter than our own star, before quietly collapsing in spectacular explosions after just a few million years. None of these magnificent stars survive in the present epoch, but their fleeting lives profoundly transformed the universe. They were the architects of the first heavy elements, gently seeding nascent galaxies with their brilliant light, and thus setting the stage for everything that followed, including the very existence of ourselves. Their direct light has long since faded, yet their subtle fingerprints remain, etched into the chemistry of ancient gas clouds and woven into the quiet, foundational structure of the early cosmos. Dark matter, a silent and unseen presence, is thought to be gently streaming through your body even as you rest. As you lie still, this mysterious substance flows quietly around you, not as some visible mist, but as a form of matter that does not interact with light. It neither reflects, emits, nor absorbs it, yet it possesses mass and responds to the gentle pull of gravity. Our own galaxy, the Milky Way, is enveloped by a vast, ethereal halo of this dark matter, and as our Earth embarks on its journey through this cosmic halo, it is believed that trillions of these elusive dark matter particles pass through every square centimeter of your body each second. They do not collide with your atoms. They leave no trace, yet they are there, ghost-like, ever-present, and profoundly essential. Without the quiet influence of dark matter, galaxies would not hold together, the grand cosmic structures we observe would not form, and the universe itself would unfold in a very different way. We still do not fully comprehend what dark matter is made of, but we know this much. It is an intrinsic part of your world, passing through you silently and continuously, even as you drift into slumber. Just as dark matter remains largely unseen in the quiet reaches of the universe, astronomers have quietly discovered galaxies that glow, yet contain hardly any stars within their vast expanse. These ghostly systems are abundant in gas and dark matter, but show little to no evidence of the vibrant star formation we typically associate with galaxies. Some of these may have gently lost their stars in ancient, powerful gravitational encounters, while others may simply have never gathered enough material to ignite many stars at all. A few remain nearly invisible, revealing themselves only in certain wavelengths of light, appearing as faint, ethereal smudges in the deepest surveys of the night sky. These quiet galaxies challenge what we once thought we understood about how galaxies form. and evolve. If they are so rich in dark matter, why haven't they built a multitude of stars? If they once held stars, where did those celestial lights go? These dim, quiet systems float through the cosmic expanse like the forgotten bones of ancient cosmic history, gently reminding us that not every galaxy is filled with blazing light. Some simply drift, unseen and unanswered, in the vast, silent ocean of space. Drifting through the cosmic tapestry, we encounter a peculiar phenomenon, a cold spot in the universe that seems to defy our current understanding. Within the gentle, ancient glow of the cosmic microwave background, the faint echo remaining from the Big Bang, there lies a region of the sky that is remarkably cooler than its surroundings. It is not merely a subtle chill, but a significantly colder and far more expansive area than scientists had anticipated. This enigmatic cold spot stretches across hundreds of millions of light years, and its very existence doesn't quite align with the smooth, random patterns we expect from the physics of the early universe. Some gentle theories suggest it might be the subtle imprint of an immense cosmic void, a vast emptiness. Others quietly ponder if it could hint at something even more profound, perhaps a whisper of our universe having brushed against another during the very nascent moments of inflation. As of now, no single explanation fully embraces this mystery. The cold spot remains one of the most quietly intriguing puzzles in cosmology. Not a jarring anomaly, but a soft suggestion that perhaps some aspects of our universe are still waiting to be fully understood. Just as the universe holds its quiet, persistent mysteries closer to home, our moon is on a slow, graceful journey away from us. Each year, this celestial companion drifts a tiny bit farther from Earth, approximately 3.5 centimeters. This gentle retreat has been unfolding ever since the moon first formed, some 4.5 billion years ago. In those ancient times, it was much nearer, and a day on Earth was but a fleeting few hours. The quiet force behind this separation is tidal friction. As the moon's gravitational embrace gently pulls upon Earth's vast oceans, and as our planet slowly spins beneath them, a subtle transfer of energy gradually nudges the moon outward in its orbit. It is a quiet, persistent process, imperceptible on the brief scale of human lives, yet undeniably clear over the span of eons. In the distant future, Earth and the moon may eventually become tidally locked, forever presenting the same face to one another. For now, it simply continues its slow, steady departure, little by little, as we quietly spin beneath its distant, glowing light. Imagine, if you will, binary stars, gently exchanging their outer layers, much like celestial dancers in a slow cosmic waltz. In certain binary systems, these two luminous spheres drift so intimately close that their outermost atmospheres begin to softly touch. As their long, quiet lives unfold, one star might gradually expand, allowing its ethereal matter to spill gracefully onto its companion, creating a delicate, spiraling exchange of cosmic material. Sometimes this transfer is a calm and steady flow, a gentle whisper across the void. At other moments, it might quietly trigger soft bursts of light, a subtle quickening of rotation, or even a serene, complete merging of their forms. The underlying physics is wonderfully intricate, yet the resulting image is one of profound, quiet grace. Two stars, forever bound in orbit, spinning just close enough to softly brush and blend. One star may eventually find itself gently stripped to a glowing core, while the other becomes quietly swollen and enriched. Their destinies, intertwined, unfold together. Indeed, some of the most extraordinary objects we observe in the universe, such as certain types of supernova or compact neutron star pairs, begin their journey as these quietly touching binaries. It is a gentle reminder that in the vastness of space, even stars can share, transform, and sometimes softly embrace. Just as these stellar destinies are intertwined, let us now consider the vacuum of space, which is not truly empty, not in the way we might first imagine. Even in the deepest, darkest reaches of the cosmos, far from the comforting glow of any star or galaxy, the universe is never entirely devoid of activity. According to the quiet principles of quantum physics, what we perceive as a vacuum is, in truth, a subtle sea of ceaseless activity. Tiny particle-antiparticle pairs softly blink into existence and then vanish almost immediately, like fleeting cosmic breaths. These quantum fluctuations occur constantly, everywhere, creating a kind of restless, underlying hum to reality itself. They can subtly influence the gentle motion of particles, affect the quiet behavior of fields, and even contribute to the inherent energy of empty space. This hidden activity is part of what gives rise to dark energy, that mysterious, gentle force that quietly accelerates the expansion of our universe. So, when we picture deep space as utterly silent and perfectly still, that image, while beautiful, is only partly true. Beneath the profound quietude lies a delicate dance of probabilities, a hidden hum of creation and disappearance, always just below the surface of what we perceive as nothingness. Time, a concept we often perceive as a steady, unwavering rhythm, may in fact flow at subtly different rates across the vast expanse of the cosmos. We tend to imagine it as a universal tick-tock, consistent for all beings, everywhere. Yet, in the quiet depths of reality, time is intimately interwoven with the fabric of gravity, the gentle dance of motion, and the very curvature of space-time itself. In regions where gravity exerts a strong embrace, perhaps near the silent pull of a black hole or within the dense heart of a galaxy cluster, time is observed to slow, relative to places where gravity's touch is lighter. This isn't merely a whisper of theory. It has been patiently confirmed through meticulous experiments, the steady gaze of satellites, and the precise ticking of atomic clocks. Still, some cosmologists quietly ponder whether time's gentle variations might extend to even grander scales. Could different cosmic neighborhoods, shaped by the universe's early, expansive moments, experience time at slightly differing paces? This idea, while speculative, softly opens the door to strange and beautiful possibilities. In a cosmos gracefully governed by relativity, even time itself may not be an absolute constant. It may subtly stretch, gently slow, or quietly bend, ever so softly shaped by the very space through which it flows. Just as time's subtle variations might remain largely unseen, our own Milky Way galaxy holds a hidden halo, a grand, ethereal embrace that extends far beyond its visible, glowing form. When our eyes gaze upon images of the Milky Way, we behold a luminous spiral, a delicate arrangement of stars, dust, and gas woven into beautiful, sweeping arms. Yet, encircling this familiar, radiant structure is something immense and largely unseen: the galactic halo. It is a colossal sphere of diffuse gas and mysterious dark matter, reaching out into the cosmic dark, far past the luminous edge of the galaxy's disk, spanning distances many times greater than the visible galaxy itself. This silent halo cradles ancient star clusters, solitary stars that have drifted far from the galactic core, and vast, unseen reservoirs of mass. It is held together by the patient hand of gravity, subtly shaped by the echoes of ancient collisions and mergers, and plays a quiet, foundational role in the galaxy's enduring stability. Though we cannot perceive it directly with our eyes, we infer its profound presence through the graceful motion of distant stars and the gentle bending of light as it journeys through space. The Milky Way, it quietly reveals, is merely the bright, beating heart of something far, far grander, a luminous core softly enfolded within invisible, cosmic arms. We have gently detected light from a galaxy that emerged just 200 million years after the universe's grand beginning, the Big Bang. Our universe, in its entirety, is thought to be approximately 13.8 billion years old. Yet the journey of light is not instantaneous. It travels through the ever-expanding fabric of space, gently stretched and softened along its immense path. This allows us a unique perspective, enabling us to perceive galaxies not as they are in this very moment, but as they existed in the deep, distant past. Quite recently, astronomers, utilizing the remarkable capabilities of the James Webb Space Telescope, were able to identify the faint glow from a galaxy that came into being merely 200 million years following the Big Bang, a mere whisper of time on the cosmic calendar. That ancient light has been gracefully making its way toward us for more than 13.5 billion years. The galaxy itself appears small, rather dim, and quite primitive. Yet within its quiet existence, it holds precious clues to understanding how the very first structures began to form. To observe it is akin to gazing through a narrow, shimmering window into a world we were never truly meant to witness. The universe in its earliest chapters, when the profound darkness was just beginning to yield to the gentle illumination of the first stars. As these earliest structures began to quietly take shape, they would eventually contribute to the large-scale architecture of the universe, which reveals a pattern that resembles a vast, intricate neural network. When astronomers meticulously map the positions of countless galaxies across truly enormous distances, a surprising and beautiful pattern quietly emerges. Galaxies are not simply scattered at random. Instead, they tend to gather together along delicate, thread-like filaments with immense, empty regions, often called cosmic voids, gently separating them. This interconnected web, stretching across billions of light years, is often referred to as the cosmic web. What is subtly captivating is that when one zooms out far enough, this grand structure appears uncannily similar to a neural network, much like those found within the quiet confines of the human brain. The dense nodes of galaxies can be seen as akin to neurons, and the graceful filaments as the axons, gently connecting them. Of course, this resemblance is purely structural. The universe itself is not engaged in thought. Yet, it remains a quietly beautiful contemplation. That the largest known structure in our universe, and the intricate network within your own mind, shaped by entirely different physical laws, can ultimately present such a strangely similar and serene appearance. Imagine, if you will, that stars possess a quiet song, a melody that drifts through the vast stillness of space. While there is no air in the cosmic expanse for sound to travel as we know it on Earth, stars still generate a form of sound, deep, slow vibrations that ripple through their internal gases, much like seismic waves moving through a planetary body. These gentle pressure waves cause a star to subtly pulse and oscillate, and scientists, with their sensitive instruments, can detect these minute changes by observing tiny shifts in the star's brightness or the delicate motion of its surface. This fascinating field of study is known as astroseismology, quite literally, the seismology of stars. Each star, in its unique celestial existence, possesses its own internal frequencies, a distinct cosmic fingerprint determined by its size, its intricate structure, and its age. By carefully listening to these stellar vibrations, scientists are able to peer deep within the heart of a star, uncovering the quiet processes unfolding beneath its luminous surface. It is a form of cosmic echolocation, a way to perceive the silent music of stars across unimaginable light years, even though this ancient song remains unheard by human ears. And as we contemplate these stellar melodies, this ancient song echoing through time, consider that some stars are, in their essence, older than the very galaxies they now inhabit. Galaxies, you see, are not born in a single moment. They evolve gracefully over immense stretches of time, gently merging with smaller systems and slowly drawing in stars and gas from surrounding regions. This means that certain stars residing within a galaxy can predate the galaxy's current grand structure. They may have quietly formed within earlier, smaller galaxies that in time merged to become the larger, more familiar celestial city we observe today. These ancient stars often find their peaceful homes in the quiet outskirts of a galaxy or within globular clusters, tightly bound groups of stars that orbit far from the galaxy's bustling core. Some of these venerable stars are over 13 billion years old, nearly as ancient as the universe itself. They carry within them the subtle chemical signature of a much younger cosmos, a time when there were fewer heavy elements and only the simplest atoms existed. These stars are like living fossils, quiet survivors from an era before the galaxy fully coalesced. Their light a gentle echo from a time when much of what we now know had yet to even begin its formation. Imagine, if you will, the quiet mystery of galaxies that appear to exist without the presence of dark matter, a substance we often consider the invisible scaffolding of the cosmos. Dark matter is thought to be the gentle, unseen force that binds galaxies, explaining why stars in their outer reaches drift with a certain speed, and why these grand stellar islands gather into vast clusters across the universe. Yet, in recent years, astronomers have quietly observed galaxies that seem to whisper a different story, behaving as if this elusive dark matter is simply not there. Their stars move with a serene grace, as if only the visible matter guides their cosmic dance. This discovery arrived as an unexpected revelation, a gentle ripple in our understanding, not quite fitting neatly into our current cosmic models. Some scientists ponder whether the dark matter might have been softly drawn away during ancient, slow collisions, while others quietly wonder if our grasp of dark matter itself is still unfolding. Regardless, these peculiar galaxies softly suggest that the universe holds many more secrets, and that what we perceive as universal truths may, in fact, be more nuanced than we once imagined. Just as the unseen absence of dark matter reveals new cosmic truths, our own sun, a familiar beacon in the sky, quietly resonates like a colossal, softly humming bell, revealing its hidden internal structure. Deep within its fiery heart, sound waves gently ripple through the plasma, gracefully bouncing from one layer to another, setting the entire star into a subtle, continuous vibration. These are not the sounds our ears can perceive. Rather, they are pressure waves, slow and profound, far beneath the range of human hearing. Yet, with the aid of sensitive instruments, scientists can detect these faint echoes, using them as a gentle guide to explore the sun's hidden internal structure. This fascinating field is known as helioseismology. By observing how the sun softly rings, scientists can begin to map the quiet ballet unfolding deep beneath its luminous surface, its density, its slow rotation, and even the unseen currents of its hot gases. In this profound sense, the sun acts like a vast, intricate musical instrument, always playing its timeless melody. We simply need the right tools to listen, and what we gently hear helps us to understand not only our sun, but the countless stars that softly glow across the universe. Imagine, if you will, that galaxies are not simply scattered randomly, but instead gently follow invisible pathways, like pearls strung along threads we cannot perceive. These grandest structures of our universe are not woven from the familiar tapestry of stars or gas, but are quietly shaped by something unseen, something we call dark matter. Over the slow, unfolding expanse of billions of years, this mysterious dark matter has gently coalesced, forming enormous, ethereal filaments that stretch across the cosmic canvas. And it is along these silent pathways that galaxies tend to gather and drift, much like beads upon an unseen string. While we cannot directly observe these filaments, their presence is softly inferred by watching how galaxies softly cluster together, and by noticing the subtle way light gently bends as it journeys through these vast, hidden regions. These cosmic filaments can quietly span hundreds of millions of light years, softly connecting immense clusters of galaxies, while in between lie great voids, nearly empty regions where very little matter gently stirs. The dark matter filaments thus act as a hidden, silent scaffolding for the visible universe, subtly guiding how galaxies grow and where they slowly journey. And yet, in this quiet cosmic dance, we still do not fully comprehend what dark matter truly is. The structure is there, immense, unseen, and quietly, patiently holding the universe in its gentle embrace. Now, just as dark matter provides an unseen scaffolding, consider the very fabric of space itself, which possesses a remarkable ability. It can stretch faster than the speed of light. Under ordinary circumstances, no object can traverse space more swiftly than light's gentle pace. However, space itself is not bound by this familiar rule. During the earliest, most fleeting moments after the Big Bang, space expanded with such profound rapidity that distant regions of the universe were gently pulled apart faster than light could ever hope to travel between them. This was not a hurried motion through space, but rather the serene, relentless expansion of space itself. Even in our present cosmic era, distant galaxies are not racing away from us because they are moving quickly through space. Instead, they are quietly receding because the very space between us and them is gently stretching. And if these galaxies are far enough away, that quiet stretching causes them to recede faster than light, which is why, in the vastness of time, we will never again perceive their gentle glow. This is not a violation of the universe's quiet laws, but rather a serene consequence of how space behaves on these grand cosmic scales. The universe does not need to rush. It simply expands, calmly and relentlessly, beyond what our eyes can ever fully follow. Our solar system, in its quiet journey, traces a path through the cosmos that resembles a gentle helical spiral. It is often comforting to imagine the planets orbiting our sun in neat, flat circles, a simple and elegant dance. Yet, if we allow our perspective to widen, to zoom out further into the cosmic expanse, a more intricate and wondrous motion quietly emerges. The sun itself is not still. It is gracefully moving, orbiting the vast center of our Milky Way galaxy at an astonishing speed, nearly 1 million kilometers per hour. As our sun embarks on this grand journey, the planets, in their turn, follow along, not merely circling the sun, but spiraling softly through space in its wake. This combined, harmonious motion creates a beautiful helical pattern, much like a slowly turning corkscrew or a gently twisting ribbon unfurling through the void. Indeed, everything is in motion, the planets, the sun, the distant stars, and the galaxy itself. There is no true stillness in space, only a graceful, ceaseless drift, an eternal cosmic ballet. Even as we rest, we are quietly tracing these slow, grand spirals through a galaxy forever in motion, wrapped within layers of orbits, nested within orbits, a dance so immense and profound that we never truly feel its gentle sway. And this ceaseless drift extends even to the deepest reaches of space, where seemingly nothing exists, yet a subtle warmth persists. If one were to journey far enough from the comforting glow of stars, planets, and galaxies into the profound quiet of intergalactic space, one would find oneself surrounded by what appears to be pure emptiness. Yet, even this profound vacuum possesses a temperature, a faint whisper of heat. That temperature hovers gently around 2.7 Kelvin, just a few degrees above absolute zero. This subtle warmth originates from the cosmic microwave background, the lingering ancient glow from the very beginning of our universe, the Big Bang. This primordial light, now stretched and cooled by billions of years of cosmic expansion, fills the entire universe. No matter how far one might drift, it is always there, a quiet, thermal signature of the early cosmos, still lingering, still measurable. And in the unfathomable future, this ancient echo will cool even further. Perhaps in a few trillion years, the universe may approach the profound stillness of absolute zero, yet it may never quite reach it, for even in the vastest emptiness, the faintest echo of heat quietly remains. Quietly, quantum fluctuations may have played a role in shaping the entire universe. At the most minuscule scales of reality, far smaller than even atoms, the universe reveals an unpredictable nature. Here, tiny, random fluctuations in energy can gently appear and then softly vanish in an instant, a consequence of the inherent uncertainty woven into quantum physics. And, as many cosmologists suggest, these brief, random blips may have been profoundly magnified during the universe's very first moments through a process known as inflation. As space expanded at an almost unimaginable speed, these tiny fluctuations were stretched and expanded to cosmic proportions. These gentle fluctuations then became the subtle seeds of structure, the quiet places where matter would eventually begin to clump, where galaxies would slowly form, and where stars would, in time, quietly ignite. In essence, the grand, sweeping structure of the cosmos, with its vast galaxies, delicate filaments, and silent voids, may all trace its origins back to these fleeting, random events at the smallest possible scale. Everything we observe today, born from what might be described as the soft trembling of nothingness. And just as the universe began with subtle rhythms, dying stars can gently pulse like distant heartbeats, echoing across millions of years. Not all stars conclude their existence with a dramatic explosion. Some instead fade more slowly, and during their final stages, they can begin to pulsate, softly swelling and then gently shrinking in rhythmic cycles. These particular stars, known as variable stars, gradually change in brightness over time. In some instances, these changes are steady and wonderfully regular, repeating like a slow, cosmic heartbeat. The pulses themselves are caused by subtle changes in the star's outer layers, where gases slowly expand and cool, then quietly collapse and heat up once more. Some of these stars pulse every few days, while others take months or even years to complete a single cycle. These rhythmic stars have long been used to measure vast distances in space, as their pulsation patterns are intimately related to their true brightness. They also serve as quiet, luminous reminders that even in their final moments, stars can continue to keep time, not with a ticking clock, but with a long, slow, cosmic breath echoing across the silent ages. Imagine, if you will, that our Earth resides within a colossal, ethereal bubble of warm gas. Should your perception extend beyond the visible spectrum, into the unseen wavelengths of light, you would discover that our solar system gently floats within this immense, softly glowing expanse of heated gas. It is known as the local bubble, quietly stretching for hundreds of light years in every direction. This cosmic chamber is believed to have been sculpted by ancient supernovae, the magnificent explosions of stars that sent gentle shock waves through the surrounding gas, warming it and clearing a path. Now, our solar system serenely drifts through this region of lower density, cradled by a shell of slightly warmer gas and dust. It poses no threat, nor is it something we can perceive with our senses. Yet it is there, a tranquil chamber around us, born from distant cosmic events long ago, now a peaceful part of the gentle tapestry of our galactic neighborhood. Just as our immediate surroundings are shaped by unseen cosmic events, so too are the grander movements of galaxies influenced by hidden forces. Beyond our local bubble, a vast, quiet emptiness lies beyond the Great Attractor. The Great Attractor itself is a profound gravitational enigma, a region of space so immensely massive that entire clusters of galaxies, including our own Milky Way, are slowly, almost imperceptibly, drawn toward its silent embrace. Yet, behind this immense concentration of matter, something even more intriguing resides, a region known as the dipole repeller, where space appears unusually vacant. It is not merely an area with fewer galaxies, it is a vast cosmic void, stretching for hundreds of millions of light years. And, in a quiet paradox, its very emptiness seems to gently guide galaxies away. Together, the Great Attractor and the dipole repeller orchestrate a subtle gravitational dance, a quiet push and pull that helps to shape the serene motion of our local universe. We are softly drawn forward by unseen mass and gently guided away by the profound emptiness beyond. It is a quiet reminder that in the boundless cosmos, both the presence of matter and the absence of it can subtly shape the timeless path we follow. Neutrinos drift silently through the Earth and through you. Right now, countless trillions of these tiny particles, known as neutrinos, are gently passing through your body, and you will never feel their presence. Neutrinos are incredibly light, neutral particles, born in vast numbers within the heart of our sun, from the distant whispers of exploding stars, and even from the very dawn of the universe itself. They interact so faintly with ordinary matter that they can journey straight through an entire planet, or indeed your entire being, without leaving the slightest trace. A precious few may encounter detectors buried deep beneath the ground, where rare, gentle collisions offer us a glimpse into their mysterious nature. Yet, most simply continue their journey, unnoticed. These particles are everywhere, all the time, silently streaming through the vastness of space and the density of matter alike. They move at nearly the speed of light, and yet, they almost never touch anything. The universe is a realm of constant, subtle motion, even when everything around us feels perfectly still. Just as these unseen particles pass through us, the most massive stars can conclude their lives by collapsing directly into black holes without a dramatic farewell. We often envision the end of a massive star as a violent supernova, a brilliant, fiery explosion that briefly illuminates an entire galaxy. However, for the most colossal stars, their final moments can be strangely quiet. Some stars are so immensely heavy that when their nuclear fuel is finally exhausted, their cores simply collapse inward. Gravity then asserts its dominion so completely, so suddenly, that even the star's outer layers are drawn directly into the void. There is no explosion, no brilliant flash of light, no bright farewell, only a sudden, quiet disappearance. This profound process is known as a direct collapse. In that instant, a star is gone, replaced by a black hole, silent, invisible, and possessing an unimaginable density. Astronomers have even observed stars that appear to vanish without a trace, as if their light simply blinked out of existence. It is a gentle reminder that not all cosmic endings are grand fireworks. Some are merely soft whispers into the deep, dark expanse. Galaxies, too, can find themselves in a cosmic dance, orbiting one another much like moons around planets. We often tend to perceive galaxies as isolated islands, adrift in the vast ocean of space. Yet, many reside in smaller groups, where they gently interact and even slowly orbit one another. Our own Milky Way, for instance, is accompanied by dozens of smaller satellite galaxies. The large and small Magellanic Clouds are perhaps the most well-known of these companions. These smaller galaxies gracefully move around the Milky Way, tracing long, elliptical paths through the quiet depths of space, much like moons in their celestial ballet. Sometimes, larger galaxies gently pull stars from their companions, forming ethereal streams and tidal tails that stretch across millions of light years. Over immense spans of time, a smaller galaxy may even be absorbed completely into its larger partner. These cosmic dances unfold over billions of years, slow, graceful interactions on a scale that our minds can barely begin to imagine. In the quietude of deep space, even galaxies can keep each other company. The universe's most brilliant explosions can emerge from the collapse of magnetic stars. There exists a rare and extraordinary type of explosion known as a magnetar hypernova, which may be among the brightest phenomena the universe is capable of producing. A magnetar is a neutron star, but one imbued with an unimaginably powerful magnetic field, trillions of times stronger than that of our Earth. If a massive star collapses into such a magnetar and releases its immense energy with astonishing swiftness, it can unleash a burst of light and energy far more potent than a typical supernova. These profound events may be responsible for some long-duration gamma-ray bursts, intense flashes of high-energy light that journey across the universe, briefly outshining entire galaxies. The explosion itself lasts only mere seconds, yet its light can reach us from billions of light-years away. It stands as one of the universe's most intense phenomena, quietly created by a small, incredibly dense object wrapped in magnetic fire collapsing in upon itself. The edge of the observable universe is not, in fact, the edge of the universe itself. When we gaze out into the cosmos, there is a natural limit to how far our eyes or our instruments can perceive, approximately 46 billion light-years in any direction. This defines the edge of what we call the observable universe. It is not a physical wall or a definitive boundary, but simply the furthest distance that light has had sufficient time to reach us since the Big Bang, considering the ongoing expansion of space. Beyond this horizon, the universe most certainly continues, vast and unseen. We simply cannot perceive it yet. And because the expansion of space is gently accelerating, some distant parts of the universe are moving away from us faster than the speed of light itself. This means their light will never reach us, not even with an infinite stretch of time. The observable universe is like a gentle bubble of vision, not the full expanse of reality, but merely the portion available to our senses. Beyond that, there are more galaxies, more stars, perhaps stretching on forever. Some galaxies quietly shoot jets of plasma for millions of light years. At the very heart of many galaxies resides a supermassive black hole, and sometimes, as matter slowly spirals toward its event horizon, not all of that matter disappears into the void. A portion of it becomes entangled in powerful magnetic fields and is then gently blasted outward in narrow, incredibly powerful jets, streams of plasma moving at speeds approaching that of light. These majestic jets can extend far beyond the host galaxy itself, reaching lengths of millions of light years. We observe them glowing softly in radio wavelengths, forming enormous, ethereal lobes that quietly mark their immense reach. Galaxies that exhibit these phenomena are known as radio galaxies, and their jets are among the largest structures in the universe. It is a strange, quiet irony. The most powerful outflows can emerge from the very regions around black holes where light itself can barely escape. Even silence, it seems, can leave an indelible mark. There is a star that orbits the Milky Way backward. Most stars within our Milky Way galaxy follow the same general direction in their orbits, gently tracing the galaxy's grand rotation. However, not all of them conform to this pattern. There is at least one known star, designated 804375439, that moves in the opposite direction. Its orbit is retrograde, quietly cutting against the cosmic flow, much like a salmon swimming upstream. How did it come to be this way? One gentle possibility is that it was once part of a smaller galaxy that merged with the Milky Way long ago, and its current orbit reflects that older, different system. Or perhaps it was flung into its present path by a powerful gravitational slingshot, perhaps involving a black hole or a dense star cluster. Either way, it serves as a quiet reminder that not all stars follow the expected rules. And even within the vast, intricate clockwork of the galaxy, there are gentle wanderers, quietly going their own way. The center of the galaxy, surprisingly, carries hints of raspberries and rum. It may sound like a whimsical notion, but it holds a quiet truth. Astronomers, while studying the chemical composition of a vast dust cloud near the very heart of the Milky Way, discovered a molecule called ethyl formate. Here on Earth, this molecule is associated with the delicate flavor of raspberries and the warm, inviting scent of rum. Of course, the galactic center does not actually possess a smell in the way we understand it. The vacuum of space would not carry scent as air does. However, the quiet presence of these molecules hints at the complex and intricate organic chemistry unfolding in the deep, silent expanse of space. There are alcohols, sugars, and even precursors to amino acids drifting within these interstellar clouds. It is not life itself, but it is the very kind of chemistry that life might quietly need. So, while space may not literally smell of fruit and liquor, it gently contains the fundamental building blocks floating silently between the stars. One galaxy is slowly heading straight for the Milky Way, and in a subtle sense, they are already touching. The Andromeda Galaxy, our nearest large galactic neighbor, is on a slow-motion collision course with the Milky Way. Right now, it rests about 2.5 million light-years away, but that immense gap is gently closing. In approximately 4 billion years, the two galaxies will begin their grand merger. And interestingly, the outer halos of both galaxies, Their vast ethereal clouds of hot gas and dark matter are already softly overlapping. So, in a quiet sense, they have already begun their gentle embrace. The eventual merger will be more of a graceful blending than a violent crash. Stars will mostly pass by one another without ever colliding. Over immense spans of time, the two majestic spirals will slowly become one larger, more elliptical galaxy. We sometimes refer to this future system as Milkomeda. It is a long wait, but the cosmic dance is already in motion, a grand meeting playing out over billions of years. The cosmic microwave background still glows softly all around you. Every part of the universe, including the very space surrounding you right now, is filled with a faint, pervasive glow known as the cosmic microwave background. It is the gentle afterglow of the Big Bang itself, light that was released when the universe was approximately 380,000 years old. Back then, the cosmos was a hot, dense plasma. When it finally cooled enough for atoms to quietly form, light was at last free to travel. That light has been moving ever since, gently stretched into microwaves by the ongoing expansion of space. Today, we detect it as a nearly uniform glow in all directions. It is not something you can see or feel, but sensitive instruments can pick it up as a kind of cosmic whisper. This gentle glow is the oldest light we can observe, a quiet signal from the universe's infancy, still echoing softly through space and time. Some supernovae are powered by an invisible collapse, not by light. Supernovae are renowned for their incredible brightness, massive explosions that briefly outshine entire galaxies. Yet, not all supernovae are luminous. Some are what astronomers quietly refer to as failed supernovae. In these profound cases, a massive star's core collapses, forming a black hole, but the outer layers do not explode outward in a visible flash. Instead, they may simply fall inward, silently feeding the nascent black hole. In rare instances, we have observed stars that seemed stable suddenly vanish from our view. No explosion, no fading glow, just the quiet onset of darkness. These disappearances suggest a collapse so complete that almost all of the energy is swallowed. There is still tremendous violence, but most of it remains hidden. It is a gentle reminder that not all cosmic deaths make noise. Some happen in profound silence. Deep within the gentle embrace of gravity, there exist entire galaxies composed predominantly of gas and the mysterious dark matter. We often envision galaxies as brilliant spirals or luminous ellipticals, each one a vast tapestry woven with billions of stars. Yet some of these cosmic islands remain almost entirely unseen. These faint systems hold but a sparse scattering of stars, their true mass quietly residing in the form of gas and the elusive dark matter. They present a challenge to our conventional telescopes, often appearing as nothing more than the softest smudges, or revealing their presence through subtle, indirect measurements across the vastness of space. Perhaps some of these are what we might call failed systems, structures that, for reasons unknown, never quite ignited into a blaze of stars. It could be that their gas was gently drawn away, or perhaps they were warmed too early in the universe's ancient history. Others may simply represent fleeting phases in the grand, unhurried dance of galactic evolution. What unites them all is a quiet subtlety. There are no grand fireworks, no sweeping, luminous arms, just a serene gravitational presence. They serve as a gentle reminder that not every galaxy needs to shine brightly. Some simply exist, drifting silently through the cosmic night. Black holes, those enigmatic voids, can sometimes engage in cosmic dances, gently colliding and merging. As two of these silent giants orbit one another, they quietly send out ripples through the very fabric of space-time, known as gravitational waves. With each gentle ripple, a tiny whisper of energy drifts away, causing the black holes to slowly spiral inward, closer and closer, until they softly merge in a final, profound moment. Two invisible titans becoming one in the vast silence. These grand collisions do not ignite the cosmos with light, but instead, they release powerful, yet unseen bursts of gravitational waves that we are now able to detect here on Earth. The very first of these subtle signals was observed in 2015, a quiet confirmation of a prediction made by Einstein a century ago. Since that time, we have gently detected dozens more, each one carrying a whispered story of massive objects colliding in distant galaxies, long, long ago. These black hole mergers unfold quietly, invisibly, yet with an incredible, silent force, transforming the energy equivalent of entire solar masses into waves that ripple softly across the universe. And for a fleeting moment, the very fabric of space itself seems to hum a gentle tune. This unseen cosmic ballet finds a quiet echo in the universe's other subtle transformations. Some stars, for instance, embark on a much slower journey toward their end, taking billions of years to softly fade away. Not every star concludes its life in a sudden, brilliant explosion. Smaller stars, much like our own sun, choose a far more gradual path. After patiently burning through their hydrogen fuel, they gently expand into what we call red giants, slowly shedding their outer layers into the quiet expanse of space. What remains behind is a dense, warm ember, a white dwarf. This luminous remnant no longer actively produces energy. It simply radiates away its leftover warmth, very, very slowly, over eons. A white dwarf can take billions of years to cool completely, gradually dimming until it becomes an invisible, silent black dwarf. However, the universe itself is not yet old enough for any star to have reached this final, completely dark stage. Every white dwarf that has ever formed is still glowing somewhere, quietly fading in the cosmic dark. The passing of these stars is less like a sudden firework and more akin to an ember cooling gently, patiently, across the vast stretches of cosmic time. Imagine, for a moment, how time itself might gently slow near the profound presence of a black hole, a concept quite different from our everyday experience here on Earth. According to Einstein's elegant theory of general relativity, gravity doesn't merely exert a pull on matter. It subtly bends the very fabric of space and time. As a gravitational field grows stronger, time itself begins to flow more slowly when compared to regions where gravity is less intense. Near a black hole, where gravity's embrace is truly extreme, this effect becomes wonderfully dramatic. If one were to quietly drift in orbit just beyond the event horizon, time for that observer would unfold at a much more leisurely pace than for someone observing from a great distance away. A few tranquil minutes spent near the black hole could, in fact, translate into many years passing elsewhere in the cosmos. This isn't merely a tale from science fiction. It is a real, measured phenomenon known as gravitational time dilation. We have even observed its milder influence on our GPS satellites, though around black holes, it becomes profoundly evident. These cosmic giants do not just quietly trap light, they gently stretch the very essence of time itself. And as space itself stretches, so too do we find, in the vast, silent stretches between galaxies, a cold unlike any we know on Earth quietly resides. Far from the warmth of stars, the gentle glow of planets, or even the soft embrace of gas clouds, these immense intergalactic spaces are astonishingly frigid. The temperature there softly descends to just a few degrees above absolute zero, settling at approximately 2.7 Kelvin. This is a chill deeper than any naturally occurring place on our planet, and colder than most environments we can carefully craft, even within our most advanced laboratories. This profound coolness arises from the near total absence of particles and energy. There is simply nothing substantial to hold heat, only a sparse scattering of stray atoms and the faint, ancient microwave glow, a gentle echo from the early universe. These intergalactic voids are among the quietest, most solitary places we can conceive. Enormous and wonderfully empty, they stretch across millions of light years, serving as the universe's deepest shadows, holding only the background whisper of creation. As the universe gently ages, it gradually becomes more transparent. In its earliest moments, light found it difficult to travel freely, for the cosmos was filled with a hot, dense plasma, a kind of cosmic fog composed of free electrons and atomic nuclei that constantly scattered every photon. Yet, as the universe expanded and slowly cooled, it reached a pivotal moment when electrons could finally combine with nuclei, forming neutral atoms. Suddenly, light was able to move unhindered, flowing through the vastness. This profound event, known as recombination, occurred approximately 380,000 years after the Big Bang, releasing the cosmic microwave background radiation that we still quietly detect today. Since that time, the universe has continued its journey, growing ever more transparent. The formation of galaxies and stars introduced new pockets of light, and as matter continues to spread out, there is less and less to obstruct a photon's long, silent path. With the passage of eons, the deep darkness has become clearer, allowing distant light to reach us. Space, once a glowing and opaque veil, now permits light to pass through almost unimpeded, a testament to its serene evolution. And it is within this ever-clearing cosmos, where light now travels unhindered, that we have quietly captured the shadow of a black hole. In the year 2019, the Event Horizon Telescope gently unveiled the first direct image of a black hole, or more precisely, the silhouette it casts. The black hole itself remains unseen, a profound void, but the glowing ring of incredibly hot gas swirling gracefully around it beautifully reveals its presence. This particular black hole resides at the very heart of the galaxy M87, a tranquil distance of about 53 million light-years away. The image reveals a perfect circular silhouette, marking the region from which no light can ever escape, surrounded by a luminous halo of radiation, gently twisted and shaped by the immense gravity. It was a monumental undertaking, requiring years of quiet global collaboration, coordinating telescopes across the entire world to function as a single, planet-sized lens. The result was far more than just a picture. It was a quiet triumph of scientific endeavor, offering us our very first glimpse at one of the most mysterious objects in the universe. Not through the realm of fiction or abstract theory, but through the gentle, persistent journey of light itself. Imagine for a moment that you can gaze upon an entire galaxy with just your own eyes, from the quiet comfort of your backyard. While most galaxies remain distant, ethereal smudges even through the most powerful telescopes, there is one that quietly reveals itself without any equipment at all. This is the Andromeda Galaxy. On those clear, dark nights in the northern hemisphere, it appears as a soft, hazy oval, a gentle whisper of light in the vast expanse above. It resides more than 2.5 million light-years away, meaning the light that now reaches your eyes began its long journey through the cosmos long before humanity itself began to stir on Earth. Andromeda holds within its embrace 1 trillion stars, more than double the number within our own Milky Way, and it is, ever so slowly, drifting closer to us. It is a profound thought to simply look up and witness an entire galaxy, without a telescope, without a filter, just the open sky, your quiet gaze, and the soft, ancient glow of something truly immense, slowly making its way through the dark. And as we contemplate this grand, slow-motion merger of galaxies, another kind of cosmic collision, equally profound, once sent a faint whisper across the universe. In the year 2015, a small, dedicated observatory known as LIGO quietly registered something extraordinary, a faint ripple in the very fabric of space-time, originating from more than 1 billion light-years away. This subtle disturbance was caused by 2 colossal black holes merging, sending gravitational waves gently outward across the cosmos. These waves are incredibly subtle. By the time they reach our Earth, they stretch and squeeze space by less than the width of a single proton. Yet, with exquisitely delicate instruments, we are now able to perceive them. LIGO and its sister observatories act like cosmic ears, patiently listening to the universe's deepest, most profound rumblings. This detection offered a quiet confirmation of a prediction Albert Einstein made a century earlier, that even in the profound silence of space, truly massive events can send out these gentle yet powerful waves. And so, we can now sense a single, soft chirp from the merger of invisible giants, quietly captured by a tiny detector on a serene corner of our small blue planet. As we gently drift through the cosmos, we come to understand that certain regions of our universe are quietly expanding away from us, destined to recede forever. The universe itself is in a state of gentle expansion, and this stretching of space is subtly accelerating, growing ever wider, ever faster. This means that some distant galaxies are being carried away so swiftly that their ancient light will never quite reach our eyes. Even if we were to wait for an eternity, the vast expanse of space between us and those galaxies would continue to grow too rapidly for their light to ever bridge the immense distance. They have, in a sense, already passed a cosmic point of no return, softly slipping beyond what we call the cosmic event horizon. Over the unimaginable stretches of time, more and more of the universe will gradually fade from our view, not because it has vanished, but simply because its light can no longer make the journey to us. This is not a change we perceive in our daily lives, but over billions of years, it suggests that our visible universe will, in its own quiet way, gently shrink. The cosmos is not merely growing, it is also, in its own profound manner, softly letting go. Contemplating these unseen, ever-receding realms, we can also ponder another deep mystery, the possibility of primordial black holes. Born in the universe's earliest moments, even before the first stars began to glow. Most black holes we know emerge from the dramatic collapse of truly massive stars. Yet, there is this other, more ancient possibility: black holes that might have formed in the very first instance of the universe, long before any stars had even come into being. These are known as primordial black holes. They may have arisen from tiny, subtle fluctuations in the incredibly dense and hot conditions that existed just after the Big Bang, where gravity gently pulled matter together into ultra-compact knots. Some of these primordial black holes could be astonishingly small, while others might have slowly grown over the eons. We have not yet directly detected one, but if they do exist, they could offer profound insights, perhaps helping us to understand the enigma of dark matter. or even seeding the formation of the very first galaxies, unlocking new secrets about the universe's infancy. They would be older than any star, older than any galaxy, silent, ancient fossils from the very first seconds after time itself began. Imagine, if you will, that entangled particles might quietly link the most distant corners of our vast cosmos. Quantum entanglement, a truly remarkable phenomenon in the realm of physics, suggests a profound interconnectedness. When two particles become entangled, their properties remain intimately linked, no matter how far apart they may drift. If one gently shifts, the other responds instantly, even across the most immense cosmic distances. While this doesn't allow for information to travel faster than the speed of light, it beautifully hints that reality at the quantum level is woven together in a deeply intricate way. Some physicists quietly ponder whether entanglement could play a subtle role in the very fabric of space-time itself, perhaps even gently helping to hold space together. In theory, particles that came into being in the earliest moments of our universe could still be entangled today, their connections stretched across the ever-expanding cosmos. If this were so, there might be quiet, invisible threads connecting distant regions, quantum echoes from the dawn of time, still softly present in the serene emptiness between galaxies. And as we drift further from the profound interconnectedness of entangled particles, let us consider the vacuum of space, which, surprisingly, holds a subtle quantum pressure. Even in what we perceive as a perfect vacuum, where there are no atoms, no particles, no radiation, there is still a gentle hum of energy. Quantum physics softly reveals that empty space is not truly empty at all. Instead, it is filled with tiny, restless fluctuations, particles and antiparticles quietly appearing and disappearing, fields subtly shifting, always in a state of gentle motion. This ceaseless, quiet activity creates a pressure known as vacuum energy. On the grandest scales, this gentle pressure may help us understand dark energy, the mysterious force that guides the universe's accelerating expansion. Unlike other forms of energy, vacuum energy does not dilute as space expands. It remains constant, gently stretching space ever faster the more of it there is. It's a profound and quiet thought that the more nothing you have, the more something it subtly becomes. This quiet, persistent force of empty space may, in its own gentle way, be what slowly drives the cosmos apart. Black holes, those famously dark and dense cosmic entities, are known for their inescapable gravity, where not even light can find its way out. Yet, as physicist Stephen Hawking revealed, they are not entirely silent. According to the delicate principles of quantum theory, black holes can emit a faint, ethereal glow, a phenomenon known as Hawking radiation. This quiet emanation occurs at the very edge of the event horizon, where fleeting virtual particle pairs momentarily appear. Occasionally, one particle gently drifts away into the cosmos, becoming real, while its partner quietly falls into the black hole's embrace. This escaping particle carries with it a tiny, almost imperceptible bit of energy, slowly, ever so slowly, diminishing the black hole's mass. Over truly immense stretches of time, this gentle leakage can cause a black hole to gradually shrink, eventually leading to its complete evaporation. For a black hole with the mass of our Sun, this serene process would unfold over more than 1 trillion years. It is the quietest kind of ending, not a dramatic explosion, but a long, slow, peaceful fade into nothingness. As we ponder these subtle cosmic disappearances and the gentle energy they release, it's worth noting that the universe holds far more plasma than solid matter. When our minds wander to thoughts of matter, we often picture the familiar states of solids, liquids, and gases. Yet, the most prevalent state of matter across the cosmos is something entirely different: plasma. Plasma is essentially an ionized gas, a tranquil cloud of particles where electrons and atomic nuclei move with a gentle freedom. We find it within the hearts of stars, carried by the solar wind, spread throughout interstellar space, and even stretching across the vast, quiet regions between galaxies. Indeed, most of the visible matter in our universe exists in this luminous, flowing state. Plasma behaves in ways distinct from other forms of matter. It responds gracefully to magnetic fields, flows with the fluidity of a cosmic river, and can carry electrical currents across unimaginable distances. Here on Earth, we encounter it rarely, perhaps in the fleeting flash of lightning, the gentle flicker of fire, or the soft glow of neon lights. But in the boundless expanse of space, plasma is everywhere, quietly glowing, steadily flowing, and subtly shaping much of the cosmic tapestry we observe, even when we are not consciously aware of its presence. Imagine, if you will, that gravity does not merely pull, but can also ripple, like a stone dropped into a vast, still pond. These ripples are known as gravitational waves, and they journey through the very fabric of space-time itself. When immense celestial bodies, such as colossal black holes or dense neutron stars, gently merge or quietly collide in the distant reaches of the cosmos, they send these subtle waves outward. As they pass, these gravitational waves ever so slightly stretch and then softly squeeze the space around them, expanding in all directions, always moving at the speed of light, the swiftest pace possible within our universe. For many decades, it was a quiet dream to detect them, requiring the development of instruments exquisitely sensitive enough to perceive such faint cosmic whispers. Yet now, from our peaceful vantage point on Earth, we can indeed listen to these distant cosmic ripples. Each wave carries with it a silent story of far-off cosmic events, revealing insights into the masses involved, the gentle spin of the objects, and even the subtle warping of space that occurred. Though silent to our human ears, these gravitational waves are profoundly real, precisely measurable, and surprisingly delicate, like tiny, unseen shutters opening and closing within the deep, ancient structure of the cosmos. Just as these ripples reveal the dynamic fabric of space-time, the universe also reveals its grand, underlying structure through what we call the cosmic web. If one could map the positions of galaxies on the grandest possible scale, a truly beautiful and intricate pattern would slowly emerge. A vast, interconnected network of luminous filaments and quiet, empty voids. Galaxies do not simply drift alone in the immense expanse. Instead, they tend to gather along invisible threads of dark matter and gas, stretching like ethereal tendrils between immense clusters. Where these cosmic filaments gently cross, we often discover superclusters, enormous, luminous knots of countless galaxies. And between these vibrant threads lie vast, serene voids, almost entirely empty, like quiet, dark oceans in the cosmic tapestry. The cosmic web is not something we can perceive all at once with a single telescope, but its magnificent structure gradually reveals itself through extensive, patient surveys of the night sky. It resembles a delicate network, perhaps a cosmic foam, or even the intricate branching patterns of neurons within a vast, sleeping mind. This is the quiet, underlying shape of the universe on its most majestic scales, not random, but beautifully woven, like something that has gently grown over eons rather than being abruptly built. The James Webb Space Telescope possesses a gentle ability to perceive galaxies that, in their original form, may no longer exist. This remarkable instrument was crafted to gaze further into the cosmic expanse than ever before, and in doing so, it also allows us to look profoundly back through the quiet corridors of time, because light, in its patient journey, requires a certain duration to travel across the vastness. Distant galaxies appear to us precisely as they were billions of years ago. Some of the luminous structures that Webb now observes may have long since merged, faded, or transformed entirely, yet their ancient light continues its arrival, a serene snapshot frozen in time, still gracefully crossing space long after its source has undergone its own cosmic evolution. This gentle phenomenon is one of the quiet oddities of astronomy. Our telescopes do not reveal the universe as it is in this very moment, but rather, they show us what was, at countless different moments across the deep history of the cosmos. Every deep field image, therefore, becomes a kind of tranquil time machine, a silent gallery of vanished light. Distant galaxies softly glow with an illumination that began its journey before our own Earth had even taken shape. When you gaze upon a galaxy several billion light-years away, you are not merely perceiving distance, you are witnessing an immense span of age. The light from that distant galaxy commenced its epic voyage long before Earth existed, before our sun began to form, and even before our solar system had quietly started to take its familiar shape. Indeed, some of the galaxies we observe today sent forth their light over 10 billion years ago. That faint, ancient glow patiently crossed an ever-expanding space, gently stretched and softened along its way, until it finally reached the sensitive instruments of our telescopes. In a profound sense, we are watching the universe's ancient past unfold in a kind of slow, cosmic real-time. The individual stars we perceive within those distant galaxies may have long since completed their life cycles, yet their light remains, a soft, enduring reminder that the night sky holds stories far older than Earth itself. Imagine, if you will, entire galaxies quietly receding from our view, veiled by soft, ethereal clouds of cosmic dust. Even something as grand and massive as a galaxy can, in certain regions of the vast expanse, be gently obscured. In these quiet corners of space, thick, drifting clouds of interstellar dust softly absorb the light from what lies beyond. This dust is not like the familiar particles that settle on a surface. Instead, it is composed of tiny, delicate grains of carbon and silicates, slowly making their way through cold, molecular clouds. When a galaxy happens to rest behind one of these gentle veils, much of its visible light can be softly muted. We then perceive its presence only when we gaze with specialized instruments, attuned to infrared, radio, or X-ray light, which can more easily drift through the dust's embrace. Astronomers have, in this patient manner, unveiled entire galaxies, quietly lingering behind what once appeared to be an empty canvas of sky. Even in the profound silence of space, appearances can be wonderfully deceptive. Darkness does not always signify absence. Sometimes it simply suggests a quiet waiting, a readiness to be seen in the appropriate light. And just as some galaxies remain quietly hidden, others reveal themselves through equally subtle, yet profound, cosmic phenomena. Some galaxies are gracefully encircled by perfect, luminous rings of bent light. Occasionally, the gentle gravity of a foreground galaxy will softly curve the light emanating from an object even farther away. If the cosmic alignment is just so, this subtle bending creates a phenomenon known as an Einstein ring, a perfect, shimmering circle of distorted light. It is a serene manifestation of gravitational lensing, where the immense mass of the foreground galaxy softly warps the fabric of space-time, acting as a natural cosmic lens for the background light. Einstein rings are rare, yet exquisitely beautiful, glowing loops suspended in the quietude of space, formed not by energetic motion, but by the gentle interplay of perspective and gravity. The light that forms these rings can originate from a distant galaxy, a luminous quasar, or even the soft echo of a supernova. These silent, perfect illusions, these natural lenses crafted by the very shape of space itself, quietly assist astronomers in measuring the mass of galaxies, mapping the unseen presence of dark matter, and softly studying the earliest moments of our universe. As we gaze upward at the quiet tapestry of stars, a gentle question often arises: could the universe truly be infinite? While our eyes can only perceive a finite region known as the observable universe, the whispers from current observations suggest that space itself might extend onward without end. Beyond what we can see, the cosmos may simply continue, an endless expanse with no discernible edge, no central point, just more galaxies, more stars, and more of the tranquil void. If this quiet truth holds, it means that much of the universe will forever remain beyond our grasp, a vast, unseen realm that we can never fully behold, no matter how far our instruments peer or how patiently we wait. An infinite universe, in its profound stillness, doesn't necessarily promise infinite possibilities, but it certainly speaks of an endlessness, a quiet vastness that stretches on, softly and without conclusion, inviting a deep sense of calm wonder. This unseen realm, so vast and distant, is not entirely silent, for even from its profound depths, tiny messengers known as cosmic rays gently arrive at Earth. Every second, these high-energy particles, composed of protons, atomic nuclei, and other fragments, quietly encounter our planet. Some originate from our own sun, while others journey from distant corners of our galaxy, or even from beyond its luminous boundaries. They are accelerated to incredible speeds by the powerful yet distant events of exploding stars, the silent pull of black holes, or other mysterious cosmic forces. Most of these particles are softly guided away by Earth's protective magnetic field, or absorbed by the atmosphere, but a gentle few manage to reach the surface, and some even pass through us, unnoticed. In these small, fleeting encounters, they are mostly harmless, yet they serve as a quiet reminder that space is not an empty void. Instead, it is alive with subtle motion, gentle energy, and invisible messengers carrying tales from events that unfolded light years away. Every now and then, a cosmic ray softly interacts with a detector, quietly sharing a story that began in the heart of a distant supernova, a particle's long, peaceful journey from a stellar explosion to the quiet expanse of your sky. As we gently drift through the cosmos, we might ponder a concept that seems natural, yet perhaps holds no true meaning. Before the Big Bang, this phrase, while intuitively appealing, may not align with the very fabric of existence as we understand it. According to the profound insights of general relativity and many cosmological models, time itself, in its most fundamental sense, began with that singular, momentous event. It was not merely the genesis of matter and energy, but also the quiet dawn of space and time as we perceive them. To inquire about what came before is, in a way, akin to asking what lies north of the North Pole, a question that dissolves upon closer reflection. Yet, some theories, like whispers in the cosmic dark, gently suggest a previous state or even an earlier universe, a grand cycle of existence. Others describe a quantum realm, where the very nature of time might behave in ways beyond our current grasp, or perhaps not exist at all. But in most prevailing models, the notion of before the Big Bang is not a place we can journey to, even within the vast expanse of our thoughts. It's important to remember that the Big Bang was not an explosion in space, but rather the quiet, profound beginning of space itself. Just as our understanding of time's beginning has deepened, so too has our perception of distant cosmic phenomena evolved. In the early days of astronomical discovery, there was a fascinating case of mistaken identity. Astronomers once quietly observed distant objects they believed to be nearby stars, which we now know as quasars. When these luminous entities were first detected, they appeared as faint, point-like specks of light, almost indistinguishable from ordinary stars. However, their light carried a peculiar signature. Their spectra were strangely shifted, and their brightness flickered in puzzling, unpredictable ways. It took years of patient observation and careful analysis to gently unravel the truth. These were not stars at all, but rather incredibly distant galaxies, each harboring an extraordinarily active heart. A quasar, we now understand, is powered by a supermassive black hole, quietly drawing in a swirling disk of hot, infalling gas. This gas, as it spirals inward, heats to unimaginable temperatures, glowing with an intensity that can, at times, softly outshine the combined light of all the other stars in its host galaxy. The light from the very first quasars observed had journeyed across billions of years of cosmic time to finally reach our telescopes, yet they presented themselves as mere tiny stars. It was a profound case of mistaken identity, which ultimately unfolded into one of the most brilliant and illuminating discoveries in the quiet, ongoing story of astronomy. Our local group of galaxies, a gentle cluster of cosmic islands, is quietly drifting toward a hidden region of space. The Milky Way, our home galaxy, does not remain still. Instead, it glides along with the majestic Andromeda galaxy and dozens of smaller companions, all part of this loose, gravitational embrace we call the local group. And this entire group, in turn, is slowly drawn toward something even grander, a gravitational anomaly known as the Great Attractor. Yet beyond even that lies a more mysterious expanse, the Shapley supercluster, and perhaps other colossal structures still veiled by the dense, luminous plane of our own galaxy. These distant, unseen masses exert a subtle, measurable pull, even though their full extent remains hidden from our view. It is as if our entire cosmic neighborhood is gently sliding towards something immense, wrapped in the deep shadows of the universe. We do not yet fully comprehend what lies in that direction, only that we are moving toward it, slowly, patiently, drawn by the quiet weight of these unseen giants. Just as these unseen forces guide our galactic journey, we find ourselves living in what might be described as the universe's stellar springtime. At this very moment, the cosmos is still abundantly filled with stars, burning brightly, forming anew, and gracefully concluding their lives in brilliant explosions. However, this vibrant period is a relatively recent chapter in cosmic history. For the first few 100 million years after the Big Bang, there were no stars at all, only a profound darkness. The very first stars eventually formed within that deep void, gently illuminating their surroundings and initiating the grand process of cosmic evolution. Since that dawn, star formation has risen, reached its peak, and has now begun a slow, graceful decline. We are currently experiencing what could be called a cosmic spring, a time when new stars continue to form, though less frequently than in the past, and far more abundantly than they will in the distant future. One day, the very last stars will be born, and after that, the universe will slowly, peacefully darken. But for now, it remains a light with new beginnings, bright enough to inspire wonder, and quiet enough to invite rest. In the quiet unfolding of the distant future, a time will come when the birth of new stars will gently cease. This celestial creation, this luminous process, depends upon the presence of cold gas, vast ethereal clouds of hydrogen and helium that, under the patient pull of gravity, slowly begin to collapse. Yet, as eons drift by, this precious fuel will gradually become scarce. It will be quietly locked away within the hearts of stars, or perhaps gently dispersed by the soft echoes of ancient supernovae, or warmed beyond its capacity to form new stellar nurseries. Billions of years from now, the grand galaxies will, in their own time, simply run out of the essential material needed to ignite new suns. The stars that remain will continue their long, graceful lives, aging, burning, and then, one by one, softly fading away. First, the brilliant blue giants will dim, then our own familiar sun-like stars will follow, and finally, even the long-lived red dwarfs will cool their slowest burning embers into the deep, quiet blackness. The universe will not conclude with a sudden, dramatic flourish. Instead, it will dim by gentle degrees, quietly and with a profound stillness. What will remain are the silent sentinels, black holes, the faint glows of white dwarfs, the dense hearts of neutron stars, and the vast, serene silence of a cosmos that has grown cold. Not a tragic end, but simply a state of deep, peaceful stillness. And as we contemplate this unseen future, we also consider another profound mystery. Most of the matter that weaves the fabric of our universe remains unseen. When we gaze upon the cosmos, observing the shimmering stars, the grand spirals of galaxies, and the delicate tendrils of nebulae, we are, in truth, only perceiving a small fraction of what truly exists. The vast majority of the universe's matter does not shine. It neither emits nor reflects the light that our eyes can perceive. This invisible substance is known as dark matter. And though we have yet to directly detect its elusive presence, we know it exists through its gentle, yet undeniable, gravitational influence. Galaxies, for instance, spin with a quiet velocity greater than their visible stars alone would suggest. Light from distant ancient objects bends with a subtle curve more pronounced than expected, and the grand clusters of galaxies hold together with a quiet strength far exceeding what their visible mass would allow. All these observations softly suggest a hidden mass, a silent presence, more than 5 times the amount of ordinary, luminous matter. Dark matter is everywhere, a quiet, unseen architect, subtly shaping the grand structure of the universe. We simply cannot see it. It is a quiet, invisible framework, patiently holding everything else in its gentle embrace. Light from the earliest galaxies has embarked on an immense journey, gently stretched by the universe's quiet expansion. As light traverses the vastness of space, it doesn't merely travel. It subtly elongates, carried along by the very fabric of the cosmos as it steadily grows. The light that began its voyage from those nascent galaxies billions of years ago has been tenderly drawn into longer wavelengths, transitioning from the visible spectrum into the infrared. This serene process is known as redshift, a fundamental whisper that allows astronomers to measure the profound distances and the ancient passage of time within the universe. The more this light has been stretched, the farther and older its source, a gentle testament to its long cosmic voyage. With instruments like the James Webb Space Telescope, we can now perceive that ancient glow, softened and reddened by its immeasurable journey, arriving as a quiet whisper stretched by the very breath of space itself. Meanwhile, the space between galaxies expands even as light travels through it. When we observe the gentle light from distant galaxies, we are not only seeing it as it was long, long ago, but also perceiving it as it has been stretched by the immense space it traversed. As the universe quietly expands, so too does the distance the light must travel. And this means that the light itself is gently stretched, its wavelength elongating, subtly shifting toward the red end of the spectrum. This phenomenon is known as cosmological redshift. The light is not slowing down or losing energy by encountering obstacles. Rather, the space it moves through is simply growing larger. In essence, the universe itself gently stretches the signal on its long journey to us. When we gaze upon faraway galaxies, we are witnessing more than just their age or distance. We are seeing how space has changed since the very moment that light began its journey. A silent, profound record of the universe's steady, gentle breathing. There are ancient sound waves quietly frozen into the very structure of the cosmos. In the early universe, before atoms had fully formed and light could travel freely, matter and energy were tightly intertwined in a hot, dense plasma. Within that primordial plasma, the interplay of pressure and gravity created subtle oscillations, ripples of compression and rarefaction, much like sound waves moving through air. These cosmic acoustic waves left an indelible imprint on the density of matter, a kind of frozen echo. Today, we can perceive that echo in the grand distribution of galaxies, a preferred distance between galaxy pairs, like a standing wave preserved in the vastness of space. This profound phenomenon is known as baryonic acoustic oscillation. It is subtle, yet measurable, a fossil record of cosmic sound ringing out from a time before the universe became transparent, a wave that never truly fades, quietly shaping the structure of everything we now serenely observe. In the quiet expanse of cosmic time, galaxies may gently merge, with smaller ones sometimes becoming part of larger celestial bodies, leaving scarcely a trace. Within the immense timescales of cosmic evolution, galaxies do not simply drift in isolation. Instead, they softly interact, occasionally drawing closer, and sometimes one may quietly absorb another. When a smaller galaxy ventures too near a more massive one, the gentle pull of gravity can gradually reshape it. Its stars are then drawn into long, ethereal streams, slowly becoming part of the larger galaxy's luminous halo, eventually blending so completely that the smaller system softly fades from our view. We have observed the lingering echoes of such mergers around our own Milky Way, with delicate stellar streams arcing through the night sky, once belonging to other distant galaxies. This serene process is often referred to as galactic cannibalism, yet it unfolds with a slow, almost elegant inevitability rather than any sudden violence. Over countless eons, grand galaxies quietly grow in this manner, not through construction, but through a gentle, silent consumption. One galaxy softly absorbed into another, leaving only a subtle ripple in the vast ocean of stars. And just as galaxies undergo their slow, elegant transformations, so too do some stars reveal their own gentle rhythms, flickering like distant fireflies in the deep night. Not all stars maintain a steady, unwavering light. Some gently pulse, softly shimmer, or quietly dim and brighten in rhythmic, almost meditative patterns. These variable stars change for a multitude of reasons, perhaps due to internal pressure waves, gentle surface eruptions, or the slow dance of eclipsing companions. From our vantage point on Earth, they appear to be softly flickering in the sky, blinking with a slow, stellar rhythm. Some complete their luminous cycle in mere hours, while others take many years. These variations are not random. Many are remarkably consistent, acting like celestial clocks in the heavens. Astronomers quietly observe them, using their steady rhythm to measure vast distances across the universe. A single repeated flicker can gently reveal how far away a star truly is, and even its intrinsic brightness. So, stars do not merely burn. Some of them, in their own quiet way, seem to breathe. Imagine, if you will, black holes that journey through the vastness of space, entirely alone. Not every black hole finds its home nestled within the luminous heart of a galaxy. Some are destined to wander. A black hole might gently be nudged from its cosmic birthplace through intricate gravitational dances. Or perhaps it could be softly ejected from a galaxy during a slow, majestic collision. Sometimes, the very recoil from a grand merger can send it drifting away. Once set free, it transforms into a solitary, rogue object, moving quietly through the interstellar medium, or even across the immense stretches of intergalactic space. These wandering black holes are, by their very nature, elusive to our gaze. They offer no light, no glow, unless they happen to pass through a cloud of gas or subtly tug upon a nearby star. Yet, it is believed they are out there, silently drifting through the profound darkness, unseen and unbound. They carry no fixed orbit, no constant companion, no familiar home. Only their immense mass, their quiet motion, and the deep, enduring gravity of a thing that once fell inward and never ceased its descent. Even these most profound cosmic anchors, black holes themselves, can be set into motion across a galaxy. When two black holes slowly merge, this powerful event sends out a gentle ripple of gravitational waves across the cosmos. However, these waves are not always perfectly symmetrical in their emission. If the merger releases slightly more energy in one particular direction, it can impart a subtle recoil, a gravitational kick, to the newly formed black hole. This gentle push can be strong enough to send it drifting away at speeds reaching thousands of kilometers per second. Some of these black holes may be softly flung entirely out of their home galaxies, destined to wander through the quiet, empty expanse of intergalactic space. Others might simply settle into wide, meandering orbits within their original galaxy. These kicked black holes, though challenging to observe, are believed by astronomers to exist. They are silent travelers, propelled by the lingering memory of their own grand collision. It reminds us that even the heaviest, most seemingly anchored entities in our universe can be set into motion by the right kind of cosmic wave. Imagine, if you will, stars that have been gently stripped down to their very cores, revealing a quiet heart of pure carbon. When a star, much like our own sun, reaches the end of its active life, it softly sheds its outer layers, leaving behind a dense, luminous remnant, known as a white dwarf. Some of these white dwarfs are composed primarily of carbon, and under the immense, patient pressure of their own gravity, this carbon may slowly crystallize. In essence, some stars quietly transform into colossal diamonds, drifting through the cosmic expanse. These stellar jewels are roughly the size of our Earth, yet they possess an extraordinary density, glowing ever so faintly with the residual warmth of their past. They no longer engage in the fiery dance of atomic fusion, but they continue to radiate a gentle light for billions of years, gradually cooling into a profound darkness. Astronomers have even observed subtle pulsations within some white dwarfs, a soft internal ringing, much like the lingering resonance of a bell struck in the deep silence of space. A silent, cooling jewel suspended in the cosmic tapestry. Once a vibrant star, now a serene crystal of ancient fading fire. These long, graceful lives of stars, transforming quietly over eons, invite us to consider the vast expanse of time yet to unfold. Supernova remnants continue their gentle expansion across the cosmos for thousands of years. When a truly massive star reaches the end of its long life, it departs in a supernova, a brilliant, fleeting explosion that can, for a brief moment, outshine an entire galaxy. Yet, the cosmic event does not conclude with that initial flash of light. The powerful shockwave quietly expands outward for centuries, perhaps even millennia, gracefully sweeping up gas, dust, and all that lies in its path. These slowly expanding shells of cosmic debris are known as supernova remnants. They softly glow across many wavelengths, radio, X-ray, and visible light, and their intricate patterns gently whisper the story of the original explosion. Some form delicate, luminous filaments, while others appear as vast, turbulent clouds. The Crab Nebula, for instance, is one such remnant, still serenely spreading outward from a blast that was observed on Earth in the year 1054. Supernova remnants are like the slow, quiet exhalations of dead stars, still unfolding their grand narrative long after the initial brilliant light has faded into the cosmic tapestry. Just as these grand narratives unfold, a gentle light from a distant star can be subtly twisted by the presence of a single, solitary planet. We often contemplate gravity's profound ability to bend light on a massive scale through the immense presence of stars, black holes, or entire galaxies. Yet, even a planet in its quiet orbit possesses this delicate power. If a planet happens to drift directly between a distant star and our Earth, it can act as a tiny, natural gravitational lens, ever so slightly magnifying and distorting the starlight that passes by. This subtle effect is known as microlensing. It is a quiet and rare phenomenon, yet it is powerful enough to gently reveal planets we might never otherwise perceive, even those residing in other distant galaxies. A faint flicker in the starlight, a gentle curve in its brightness, and suddenly, a hidden world is softly revealed. The planet itself might remain cold, dark, and entirely invisible to our direct gaze, but its silent presence subtly twists the starlight ever so slightly, and that gentle twist is enough to quietly announce, "I am here." Imagine, if you will, a time when the universe itself glowed with a soft, brilliant orange light. In those very early days, just after the Big Bang, the cosmos was a hot, dense plasma, radiating an intense, all-encompassing light. But as it began its gentle expansion and gradual cooling, that pervasive glow slowly shifted. When the temperature eventually drifted down to approximately 3,000 degrees Kelvin, a profound change occurred. The very first atoms quietly formed, allowing light to travel freely through space for the first time. In that serene moment, the entire universe would have appeared a warm, comforting orange. Not the deep, cool blue-black of the night sky we gaze upon now, but a soft, radiant warmth, filling every corner of existence. This ancient light has since been stretched and softened by the continuous expansion of the universe, transforming into the faint microwave glow we quietly detect today, known as the cosmic microwave background. Yet, long, long ago, there was indeed a time when the entire cosmos glowed orange, as if lit from within, a quiet ember slowly fading into the vastness of time. As this grand cooling unfolds, a process that began with the universe's initial orange glow, it's interesting to consider that some parts of the universe are cooling more slowly than others. The universe expands, and with that expansion, it cools gradually, gently, much like a vast cosmic oven being slowly turned off. However, not every region cools at precisely the same rate. Certain areas, perhaps those filled with a greater concentration of matter or trapped light, tend to retain their warmth for longer periods. For instance, the immense clusters of galaxies contain hot gas that can remain warm for billions of years, a testament to their enduring energy. Meanwhile, other regions, more isolated and less dense, tend to chill more quickly. These subtle temperature differences quietly influence how cosmic structures gently form, how stars gracefully evolve, and how long certain celestial processes can serenely last. Even within a universe governed by grand, simple rules, there are always these local variations, these warmer pockets, these slower fades, small, quiet delays in the great, unfolding tapestry of existence. The universe does not cool like a precise machine. Instead, it cools much like the weather, uneven, beautifully textured, and quietly, profoundly alive. We might, in some distant future, quietly observe the birth of a new universe. Some gentle theories of cosmology suggest that new universes could softly form within our own, perhaps budding off through subtle quantum fluctuations, or from the heart of black holes, or through other quiet mechanisms we do not yet fully comprehend. If such an event were to unfold, it would likely occur far from our reach, beyond any observational horizon. Yet, in theory, it might be possible to perceive the faint signs, a sudden, expanding bubble of new physics, gently tearing away from our familiar reality. We do not know if this has ever happened in the long cosmic night. We do not know if it ever will. But the quiet idea remains that somewhere, someday, the deep silence of our universe could give birth to something entirely new. A beginning nestled within an ending, a soft whisper emerging from a profound silence. Meanwhile, the cosmos continues to resonate with echoes from its earliest moments. In the first fleeting fraction of a second after the Big Bang, the universe expanded with an explosive grace, an event known as inflation. That initial burst of motion left behind subtle ripples, tiny quantum fluctuations stretched across the vastness of space. These ripples quietly became the seeds of all future structure, the galaxies, the stars, the planets, and they also left behind enduring echoes. We perceive them now in the cosmic microwave background as gentle temperature variations, and we may one day detect them as primordial gravitational waves, faint, rhythmic pulses in the very fabric of space-time itself. The universe may seem quiet now, but it still carries the memory of that first vibration, like a bell still humming softly, long after the initial strike. The universe is vast, and you are a gentle way for it to know itself. Of all the quiet wonders in astronomy, perhaps the most softly astonishing is this: you are made of stardust, the carbon that forms your body, the calcium that strengthens your bones, the iron that flows in your blood. All were forged in the hearts of ancient stars, scattered across the cosmic expanse, and then gently gathered into life. You are not separate from the cosmos. You are a quiet moment of it made conscious, a soft flicker of awareness in a universe that otherwise only moves and burns and cools. In this gentle sense, the universe has grown eyes, and through those eyes, it looks back at itself, wonders at itself, and quietly dreams of itself. And even now, As you drift towards sleep, it continues its endless dreaming. Thank you for spending this time here, floating through the cosmos with me. We have journeyed across vast distances, past the quiet glow of dying stars and the soft light of newborn galaxies, listening to the ripples in space-time and the echoes from the earliest moments of creation. And somewhere in all of it, in the light of ancient stars, in the silence between galaxies, in the quiet shimmer of dust, there was you, breathing slowly, your thoughts softening, perhaps even already asleep. This universe is full of motion and mystery, but also profound stillness. It holds heat and light and gravity, but it also holds a deep peace. And the fact that we can know it, piece by gentle piece, in calm and in quiet, is something truly beautiful. So wherever you are now, whether you are fully awake or drifting beyond the edge of thought, may your dreams tonight be gentle. May your body rest like starlight on water. And may you carry with you, even faintly, the memory of a universe that glows, not just above you, but softly within you. Good night.